a central focus in Module 1 is on a review of random variables and Gaussian probability distributions. So in this video, we solve an example regarding these concepts. Consider two random variables, x and y, that are distributed on the plane according to this formula. So the PDF is 0 in regions where x, y is negative. In the first part of the problem, we are required to calculate k. To do this, remember that fxy is a probability distribution function. So its integral over the whole plane should equal 1. So we have 1 equals the double integral over the whole plane of fxy dx dy. Now note that in regions where xy is negative, the probability distribution function is 0, and hence its integral is also 0. So we just need to do the integration over the two shaded areas as shown in this figure. So this equals the double integral from minus infinity to 0 k over pi exp minus x2 plus y2 over 2 dx dy plus the double integral from 0 to infinity of k over pi exp minus x2 plus y2 over 2 dx dy. To do the integration, note that the integrand is separable with regard to x and y. So we can write this equals k over pi the integral from minus infinity to 0 exp minus x2 over 2 dx multiplied by the integral from minus infinity to 0 exp minus y2 over 2 dy plus similar calculations for the other term. The integral from 0 to infinity exp minus x2 over 2 dx multiplied by the same term dy. To calculate this, note that this term here is an scaled Gaussian PDF, and scaled standard Gaussian PDF, and it's integrated over half the axis. So from the Q function, we know that this equals 1 over 2 radical 2 pi. Similarly, this is the same, 1 over 2 radical 2 pi. And the similar argument holds for the other two terms. So we get k over pi 2 multiplied by 1 over 2 radical 2 pi to the power of 2. And we know that this whole thing equals 1. So we easily get k equals 1. In the second part of the problem, we are asked to show that x and y are Gaussian random variables. And to show this, we derive the marginal PDFs for x and y and show that it's compatible with the general Gaussian formula. So, for example, let's start with x. We need to derive fx x, and we know that this equals the integral of the joint PDF fxy dy over the whole axis. To calculate the integral, let's consider two different cases where x is positive and x is negative. When x is positive, this equals the integral from minus infinity to 0 fxy dy plus the integral from 0 to infinity fxy dy. Now note that in this case x is positive, and for the second term where for the first term where y is negative, then xy is negative, and so we have the first term equals 0. And for the second term we can just replace from the general formula. So we can proceed with the integral from 0 to infinity and k over pi exp minus x2 plus y2 over 2 dy. Okay, we know that k is 1, and x is independent of y, so we have this equals 1 over pi exp minus x2 over 2, the integral with regard to y from 0 to infinity exp minus y2 over 2 dy. And to calculate this, again note that this term is an scaled standard Gaussian PDF, and the integration is over half the axis. So this equals 1 over 2 radical 2 pi. And hence, the whole thing is 1 over radical 2 pi exp minus x2 over 2. And this is the general formula for zero mean Gaussian PDF. But this holds only for half the axis, and we need to show that for the other half the same formula holds. So for this half we have fxx equals so if x is negative, then we need to do the integration over the negative part of the y-axis so that xy is positive and the joint PDF is non-zero. So this is from minus infinity to 0 k over pi exp minus x2 plus y2 over 2 dy. And again, this is 1 over pi exp minus x2 over 2, the integral from minus infinity to 0 exp minus y2 over 2 dy. And this is again a standard normal PDF that is integrated over half the plane. So again, this is 1 over 2 radical 2 pi. And finally we get this equals 1 over radical 2 pi exp minus x2 over 2. So for every x, the PDF equals 1 over radical 2 pi exp minus x2 over 2. And this is the general formula for a Gaussian, for a zero mean Gaussian PDF. And hence we have shown that x is a zero mean Gaussian, standard Gaussian PDF. And for the symmetry of the problem, we can take similar steps for the random variable y and show that y is also a Gaussian PDF with zero mean and variance 1. And that's all for this part of the problem. In the third part of the problem, we are asked to say whether x and y are jointly Gaussian. This is obviously not true because the joint PDF given here is not compatible with the general PDF for jointly Gaussian random variables. For example, if xy is negative, then fxy is 0 here. But for jointly Gaussian random variables, we know that over the whole xy plane, fxy is non-zero. So jointly Gaussian does not hold for x and y. And finally, in the last part, we are asked whether x and y are independent. We know that for x and y to be independent, we should have the joint PDF fxy. This should equal fx multiplied by fy. And again, this does not hold because in case where xy is negative, we have the joint PDF equals 0. But for each of the marginal PDFs, we showed in the second part of the problem that this is non-zero, and so this is not 0, and this is also not 0, and so this does not hold. And so x and y are not independent. And that's all for this example. Thank you very much.